Hi everybody, my name is Rafael Laufer and Technical Fellow at Impinj. My professional background consists in more than 10 years of customer service and RFID product development. In this period, more than 8 years was directly acting in electronic tolling in Brazil. I would like to thank Megan to organize this event and invite me to speech. And now, we will talk a little about the Brazilian toll collect system. This very old cartoon shows the actual issue. We want to control and track objects, warranty its authenticity, but we want to keep our individuality and privacy. Today, the problem of clandestine RFID tracking and inventory are limited concerns since RFID infrastructure is scarce and fragmentary, and expressive item tagging some years away. Once RFID became pervasive, however, the privacy problem will assume a great dimension. The presage of it is the toll collect system in Brazil. It creates a unified view of individual tags across organizations, like banks, parking lots, and gas stations. This figure illustrates the problem of clandestine RFID inventory as it might emerge in future. In all attacks, hackers want to get an improper advantage. These are a short list of most common attacks to tag and readers. Reverse engineering. Hackers would take apart the readers or tag in order to find how it works or to receive data from ICs, to steal information or gain access on a system. Power analysis. This attack can be mounted on a RFID system by monitoring the power consumption of RFID tags or readers or its electromagnetic emission to recover crypto keys, for example. Eavesdrop and reply occurs when an unauthorized RFID reader listens the communication between a tag and reader, then obtains important data. Sometimes this information can be replied in another communication. Man in the middle or sniffing. The hacker intercepts and diverts the original signal and then sends a false data while pretending to be a normal component on a RFID system. Denial of service. These attacks are usually physical attacks, like jamming the system with noise interference, blocking radio signals, or even removing or disabling RFID tags. Cloning and spoofing. Cloning is duplicate data from a pre-existing tag, and spoofing is then using the tag cloned to gain access to a security error or item. Viruses. RFID currently do not have enough memory capacity to store viruses, but in the future could be a serious threat on a RFID system. This issue could be very similar which to occur on personal computers in our days. To meet toll collecting market demands, the tags and the system must meet some requirements and challenges. For requirements, the list can be toll collecting, which is the main objective, give support to other private enterprises generating ancillary revenues like allow access to parking lots or payment at gas station. Traffic control and monitoring, for example, generating an automatic traffic ticket. On the other hand, the main challenges are security and data privacy, high-speed reading, decision in transit time, in other words, a low-latency system, and the more important point, right to individual privacy. Right to privacy was angular stone in the toll collecting development in Brazil. The Brazilian Constitution, the Bill of Rights, define as inviolable the right of people to be secure in their person, houses, and papers. Under the argument of the right to privacy, automatic identification technology have been discussed worldwide. Whenever such information may lead directly or indirectly to the identification or even the location of people. The right to the privacy issue can be summarized in the identification tags, and ultimately their owners can be revealed to unauthorized parties without owner's approval or even their acknowledgement. Primary objective of a RFID system is identification, but there are two secondary goals that most RFID systems aim to satisfy: privacy and security. The discussion between the primary and the secondary goals could explain the market fail of a privacy-friendly solution for a RFID system. In order to meet these issues, some suggestions can be applied. Tag authentication is a basic requirement, something like TAN1, and the transaction of sensitive data by an encrypted way is rarely recommended, something like TAN2. No information directly related to the vehicle or its owner must be openly recorded in the memory tag. SJ5511, the protocol used in the Brazilian toll collect system, is an extension of ISO 18000-6C with intention to meet the needs for privacy and security pervasive in law. In this way, the protocol defines operating procedures and commands for roadside unit, as the reader and roadside computer sets called, and onboard unit, or the tag, in order to guarantee the security and authenticity communication through commands. Onboard unit customization and activation procedures to guarantee the uniqueness and the correct information. Onboard unit memory map allocation in order to ensure interoperability of the service. Security mechanisms to meet legal and personal requirements. And transaction models and operational requirements to achieve the required performance. Here we can see some performance metrics and specifications. The most important are AES 128 bits of cryptography, ability better than 98% of read success for toll with mechanical barrier and for multi-lane free flow. Power supply, passive tags are preferred, although battery assisted tags are allowed. 128 bits of encrypted user data. At the figure we can see the system as a multi-disciplinary solution with sensors for detect the vehicle, video cameras, optical character recognition, and RFID readers. All this to increase the confidence in the system. I would like to introduce you to three important elements in SJ5511 system. AGC, the key management system, the most important element in the system. It is responsible for managing system keys and group ID and unique identification number recorded on memory of onboard unit. Following, we have the GID, Group ID, or Identifier of Groups for Cryptographic Keys. The keys used for reading the transponders are grouped in group of thousands, while the OBUID are unique for each transponder. Finally, we have ACT, Transponder Configuration Equipment. This equipment is remotely controlled by AGC and must guarantee that there is only one tag in the right field during the tag configuration to avoid sniffing, cloning, or spoofing attacks. I would like to present a simplified view of SJ5511 ecosystem. First of all, everything starts at AGC and Central Toll Systems, tagged with number 1. As we discussed in the last slide, the most important part of this infrastructure It controls all data input and output using VPN and HTTPS channels, and it is a giant database where is stored all vehicular passage and financial transactions. Using this data, the system can start billing information and generate dashboards. Also, it creates the crypto keys and manages its distribution. This activity can be decentralized, but we will keep it as a centralized representation to simplify this drawing. Tagged with number 2 is the chip. It is mounted on tag and it runs a specific protocol as we talked about. IC is tested and initialized with a specific test data and a unique TID. No data record in this phase will be used in the future except TID. TID memory contains the standard value to select the tag and a tag manufacturer number, not a mask manufacturer ID like in the EPC. Tagged with number 3 is the tag manufacturer. Generally is used a special antenna design for automotive glass. This design shall provide a tamper to signalize or avoid a current response if there was an attempt to removing the tag. Here, tags will receive the graphism, visual identity, and a unique QR code. Here, tag will be commissioned by AGC through ACT, receiving a unique OBU ID and a crypto key according to its group ID. From this point, no individual data can be read without crypto keys and crypto command. Now, at step 5, after the purchasing the tag, end user will activate it with the bank using a app on the cell phone. This app will communicate with AGC to associate bank data and vehicle data with the tag. After this point, OBU ID will represent this vehicle in particular on its crypto transaction. Vehicles can travel with more than one tag on windshield without conflicts because reading on toll system execute a select command over a specific data in TID before starts communication. Step 7. When a vehicle that has a tag that meets the SJ5511 protocol pass under a RFID reader at a toll place, the tag is selected and a specific memory area is read using a custom command and the encrypted data is returned. Step 8. The encrypted data and the GID are sent to roadside unit where the information is decrypted and compared with the blocking list and unblocking list in order to open or not the mechanical barrier. This information is sent to AGC and the loop is closed. The roadside unit is there to keep the system latency low because the system has few seconds to open the barrier. At number 9, we can see the channel over the list and keys are updated. The time lapse from step 5, when the tag is associated to a vehicle, and the success passage at steps 9 and 8 is about 4 hours. On the other hand, a passage has 10 minutes to be built. This metric is valid only in São Paulo state. The toll collecting system in Brazil operates with two lists. The block list. This list has a logic OR. In other words, if the tag has any issue, its OBU ID will be recorded in this list. Examples of issues are commissioned but without vehicle associated, financial problem, no funds, stolen, broken, replaced. For the unblock list, this list works with a AND logic. In other words, if tag has no issue, its OBU ID will be registered in this list. For example, be commissioned, has a vehicle associated, has no financial problem, has no technical restrictions. Before customization, the tag behaves like a standard EPC tag. After customization, no information that uniquely identifies the tag is available for read without the usage of crypto keys and crypto commands. Before of the customization, the reserved are open for read, write, and select. The EPC, also called UEE, is open for read, write, and select. TID is open for read and select. User is open for read, write, and select. After the customization, the reserved memory is totally hidden. The EPC is open for read and select. The TID is hidden except for select over words 1 and 2, and the user memory is totally hidden, but it can be retrieved by a customized crypto command. This is not the real command used on SJ5511 protocol, but an approximation, an extrapolation from the EPC Gen 2 v2. We cannot talk directly about these commands because they are under a NDA. In this custom key protocol command has a fixed frame without address and data length. The only field to be filled is a random number with 96 bits. This command has the same functionality as the 10.2, but it is quite simple. The answer has a fixed payload size with 260 bits, but 128 bits are random numbers to avoid some attacks. For this command, T1 time from interrogation transition to tag response must be smaller than 3 milliseconds. In the EPC v2, there is a possibility to use an in-process response to inform the reader that the cryptographic response is not read, but this leaves the system non-deterministic. SJ5511 don't leave this possibility. After this very fast and superficial overview, I would like to remark and highlight some points. 1. The use of RFID for tolling is beyond the point of no return because there are many successful applications around the world, for example in Brazil, USA, and Europe. The market size and the benefits to the population are very positive. 2. A low latency system with a good list management are critical. In this way, the costs and the development of a robust infrastructure should not be neglected. 3. System security and user privacy issues need to be planned from the first day of the system in order to meet user demands and legal regulation. Insecurity and disapproved system by the population shall not generate the expected return. 4. The security and the performance metrics of the tags and the systems need to be periodically reviewed in order to meet new demands and prevent new attacks. We have come to the end of this presentation. I would like to thank you for your attention and time. If you have any questions, just let us know. Thanks and see you.